Hello, and welcome back to another IB Math speedrun with me, Vince. In this speedrun, we're going to be going over chapter 7.1 of the textbook, which is all about integration. So let's jump right in. Sorry about that. Anyways, as I was saying, in calculus, there are essentially two branches. One is differentiation, which we've already covered a lot about it, and the other major branch we need to know about is integration. So we know that differentiation allows us to find the tangent of a line. Well, what it's important to realize is that integration is essentially finding the original curve from the tangent on the line. So differentiation is converting a function into its derivative, whereas integration is essentially getting the original function from its derivative. So what does integration look like? Let's say we want to integrate the function 2x. So 2x is essentially the derivative of our function. And we have to put dx here because we need to integrate 2x with respect to x over here. So, well, we call 2x here the integrand because it's what we're integrating. So what this will equal is this will become x squared plus c. Why is it x squared plus c? Well, it's because we should be able to differentiate whatever is here in order to get whatever derivative we have. If we differentiate x squared plus c, where c is a constant, real number, then we get 2x, if you remember. And so yeah, that is why this is the integral of 2x. So c is called the constant of integration because without knowing anything else about the curve aside from its derivative, we don't know what constant is applied to it. Because remember, the constant is removed if we differentiate the curve. So in general, we say that the integral of a derivative is equal to the original function plus c, where because we don't know exactly what constant was added to the function. So technically these are not the same function. It's just f and then another function where the derivative of f is equal to the other function. So unlike differentiation, where if you differentiate a function, there's only one answer, if you integrate a function, there can be infinitely many answers because there can be infinitely many functions that can be derived to get this function in here. So yeah. So we have a bunch of general rules that I'm going to sum up for you for integration. First of all, if we're integrating some number raised to a power, this will equal the number raised to the power plus 1 divided by n plus 1 plus c. And you can see why if you try and differentiate this function, you will get x to the n. For all of these rules, you'll see that if you differentiate this side, you get this side, and so we can apply it in reverse. Next, if we're being multiplied by a constant, we can actually take any constant that's being multiplied out of the integral. So this will become kx to the n. Next, if we are differentiating some composite, composite function, a n x to the n plus a to the n minus 1 x to the n minus 1, we can actually split these terms apart. So this is actually equal to a and the derivative of x to the n plus the integral of x to the n plus the integral of the next term, and so on. So it's very handy to know that we can split apart integrals like this, just like we can split apart functions when we derive them. It's the same as the sum and difference of the rule. So we know how to differentiate this. How about the trigonometric functions? Well, we know that d over dx sine x is equal to cosine x. So conversely, if we take the integral of cosine x, this should be equal to sine x plus c, because it's the reverse of differentiation. Likewise, the integral of sine x is equal to negative cosine x plus c, and the integral of secant squared x is equal to tangent x plus c. Yeah, and so when certain information, if we're given more information about the actual curve, like normally if we're given a point on the curve, in addition to a formula, if we go back to our example, we need to integrate 2x, and we know that a point on the original curve is, I don't know, 0, 1. We can use this information to get the full original curve because we can use it to find the constant by plugging the coordinates in. So yeah, so the next thing we need to cover is reverse chain rule in a sense. So if you remember, if we differentiate something like ax plus b to the power of n, we will get n times an times ax plus b to the n minus 1. So we can use this in reverse. So we can say that the integral of ax plus b to the n is equal to ax plus b to the n plus 1 over a times n plus 1 plus c. So yeah, this is very handy to know this. And I think we're going to go on to more about reverse chain rule later on because that can be a lot trickier. But in this case, this is the basics. I mean, it also works for other functions. For example, the integral of sine ax plus b is equal to negative cosine ax plus b divided by a plus c. So yeah, I think knowing that, we can jump into some questions now. So first question we're going to have is find the indefinite integrals of the following functions. So an indefinite integral is, well, it's an integral with the constant of integration in it, where we don't know the actual function because it's a set of functions. So anyway, the first one is negative 2/3 x dx, and so we need to integrate this. So this will be equal to, well, we know that if we have something like ax to the n, the integral will be will be equal to ax to the n plus 1 over n plus 1. So in this case, our coefficient a is equal to negative 2/3 x. And so this will be equal to negative 2/3 x squared all over n plus 1, which is 2 plus c. And since we're dividing 2 by 2, so we simply get negative x squared over 3 plus c. So that is how you integrate a function. Next, we have the integral of 4x to the 3/2. Okay, so first we add 1 to the power, so we get 5 over 2, x to the 4, and then now we have to divide by this new power, over 5 over 2, plus c. So we can simplify this a bit by multiplying 2 to the top, so we have 8 over 5, x to the 5 over 2, plus c. So this will be our new function. Finally, we have 2 sine x over 2 cosine x over 2. And so in order to integrate this, we need to apply the double angle formula. So we can actually convert this. This is equal to the integral of simply sine x. Since if we split this into double angle, we get 2 sine x over 2 cosine x over 2. So for integrating sine x dx, we will get negative cosine x plus c. So yeah, that one was pretty simple. Okay, on to the next one. We need to integrate the following functions with respect to x. So the first is x to the 4 plus 4x cubed minus 3x to the negative 3 plus x to the negative 4. And just like we covered, we can actually split this apart into different integrals and integrate each term separately. So we have the integral of x to the 4 plus the integral of 4x cubed plus the, or actually we can just, plus the integral of minus 3x to the negative 3 plus the integral of x to the negative 4. So if we integrate each of these terms, this is 1/5 x to the 5 plus x to the 4. I'm just doing this by sight, but you can see that if we integrate 4x to the 3, this will be equal to 4x to the 4 over 4, so it's simply x to the 4. Minus 3x cubed, so this would be plus, I guess, 1/2. No, so minus 3 over 2 plus 3 over 2 x to the negative 2. Minus 1/3 x to the negative 3. Yeah. So this should be what we get if we integrate that function. Next, we need to integrate 2 minus x cubed. And so yes, we could expand this and integrate it this way, but it's better to use the reverse chain rule in order to integrate it. So we know this is going to actually be equal to the coefficient here, which we don't have any. Sorry, not the coefficient there. This number over here, plus 1. So it's going to be negative 2x minus x to the 4 over 4 times negative 1 over here, since the coefficient of x is negative 1. So this will be equal to negative 1/4 times 2 minus x to the 4. Okay, on to the next question. Next question is find y is equal to f of x, given that dy over dx is equal to 3x squared minus 4, and f of negative 1 is equal to 2. So we need to find the original function. So let's integrate 3x squared minus 4, which will simply be equal to x cubed minus 4x, so plus c. And so now we need to plug in this additional information in order to get constant. So we know 2 is equal to negative 1 cubed minus 4 times negative 1 plus c. It's equal to negative 1 plus 4 plus c. So we have c is equal to negative 1. So since c is equal to negative 1, the original function y must be equal to x cubed minus 4x minus 1. So that is the answer. Okay, on to the next one. We have, I'll type this out. So given that y is equal to 2 when x is equal to negative 1, and dy over dx is equal to 2x minus 1 cubed, find y in terms of x. So we have the point negative 1, 2 on the curve, and so we have to integrate 2x minus 1 cubed. So if we raise the power by 1, this will be equal to 2x minus 1 to the 4th, all over 4 times 2, since if we differentiate the inside, we get 2. So this is effectively 1/8 times 2x minus 1 to the 4th. And so we know the point that negative 1, 2 lies on this curve, so we can say 2 is equal to 1/8 times 2 times negative 1 is negative 1 minus 1 is 3 to the 4. So this is plus c. I forgot my plus c. So we have, this is equal to 81 over 8 plus c is equal to 2. So c must be equal to 16 minus 81 over 8. So we have 16 minus 81, so c must be equal to negative 65 over 8. So the original equation, y, must be equal to 1/8 times 2x minus 1 to the 4th minus 65 over 16. Over 8. Yeah. So that sounds good. Okay, on to the next one. We're given that f prime theta is equal to 2 minus 3 sine theta. Find the function of f given that f 0 is equal to negative 2. So let's integrate this. We have the integral of 2 minus 3 sine theta. And so this will be equal d theta. So this will be equal to 2 theta plus 3 cosine theta. So plus c. And so we're given that f of 0 is equal to negative 2. So negative 2 is equal to 3 cosine 0, which is 1. So 3 plus c. So we know that c must be equal to negative 5. So the original function must be 2 theta plus 3 cosine theta minus 5. Yeah. So that would be the answer here. Okay, on to the next one. In parts A to D, find f of x with the given conditions. Okay, so we have first f prime of x is equal to 2 over cosine squared x minus 3 sine x, and f of 0 is equal to 4. So let's solve this. So if we take the integral of that, we know this is simply equal to 2 tan, the integral of 2 secant squared x minus 3 sine x is equal to 2 tan x plus 3 cosine x. So plus c. And we know that f of 0 is equal to 4. So effectively, 4 is equal to 3 cosine x, which is 0, so 3 plus c. So c must equal 1. So we have f of x is equal to that. Okay, on to the next one. We have f double prime x, so the second derivative is equal to 2 plus 3 cosine x. F prime of 0 is equal to 4, and f of 0 is equal to 5. Okay, so first let's get the first derivative, f prime. X should be equal to the integral of this, 2 plus 3 cosine x, which is simply 2x minus 3 sine x. Oh, sorry, 2x plus 3 sine x. Yep. And so f prime of 0 is equal to 4. So if we put 0 in, 4 is equal to plus c. Since both 2x and 3 sine x should be equal to 0 when f is equal to 0, c must equal 4. So we have plus 4. So next we need to integrate this to get the original function. So this should be x squared minus 3 cosine x plus 4x plus c. And we're given that at 0, this original function is equal to 5. So we have 0 is equal to negative 3 plus c. Oh, sorry, 5 is equal to negative 3 plus c. So c must be equal to 8. So our new function is x squared minus 3 cosine x plus 4x plus 8. That should be our function. Okay, next, the final question is a particle moves in a straight line such that at time t seconds, its acceleration is a of t is equal to 6 cosine t. When t is equal to 0, its velocity is 0 meters per second. And when t is equal to pi over 3, its displacement is 2 meters from the origin. So we need to find expressions for the velocity and displacement at time t. Okay, so this is pretty simple because we know that a of t is equal to the second derivative of the displacement function, and v of t is equal to the first derivative of the displacement function. So we have the second derivative is equal to 6 cosine t. So if we integrate this, the first derivative should be equal to 6 sine t plus c. And we know this is the velocity, so when t is 0, its velocity is 0. So at this point, c should equal 0. So the velocity function should look like 6 sine t. Now let's integrate this again to get the displacement function, which is negative 6 cosine t plus c. And we're given that when t is pi of 3, the displacement is 2 meters from the origin. So 2 should equal negative 6 cosine pi over 3. And the cosine pi over 3 is equal to 1/2. So this is equal to negative 3 plus c, so c equals 5. So the displacement function should be negative 6 cosine t plus 5. So yeah. We have, I think, 2 more questions. The first one is integrate the following. 3 times 4 minus x to the 1/2 dx. So we need to integrate this function. How we're going to do that is we can just use reverse chain rule on the spot. So this is equal to add 1, so 4 minus x, 3 times 4 minus x to the 3/2 over 3/2 times negative 1. Since if we differentiate the inside, it's equal to negative 1. So we can cancel this out. So it equals negative, I believe, 2 times 4 minus x to the 3/2. So this would be the integral. And finally, we need to integrate, plus c. Plus c. Sorry, never forget that. Finally, we need to integrate 2 times 2 minus 3x to the negative 1/3 plus 1 plus 2x to the 1/3. So this is equal to 2 times 2 minus 3x to the 2/3 over 2/3 times minus 3 plus 1 plus 2x to the 4/3 over 4/3 times 2. So this is equal to, you can cancel those 2 out, cancel these 2 out, so we're left with negative 2 minus 3x to the 2/3 plus 3 over 8 times 1 plus 2x to the 4/3. So yeah, that should be the answer to the final question. So that was all for the speedrun. I hope you enjoyed it, and I hope to see you in the next one. See you then.